So after completion of this topic, students should able to understand the concept of DRC. DRC nothing but the dose response curve. Then to locate abdominis muscle on abdominal wall of frog. The next one is to isolate rectus abdominis muscle of frog. Then to understand and observe the potentiation effect of acetylcholine in presence of physostigmine by using isolated rectus abdominis muscle of frog. So these are the learning outcomes of today's practical. So next, that is aim. So aim of today's practical, as we have discussed, to study the effect of physostigmine on DRC of acetylcholine using frog rectus abdominis muscle. Then next one is the references. So there are two references for performing today's practical. So book of S.B. Dhade, a handbook of experimental pharmacology, Studium Press Private Limited, New Delhi, page number 94 to 96. And second reference, that is the book of S.K. Kulkarni, handbook of experimental pharmacology, Vallabh Prakashan, New Delhi, page number 102 to 104. So these are the references. So next we will discuss the requirement. So what is the requirement for today's practical? So requirement, animal. So it requires frog for isolation of rectus abdominis muscle. Then it requires PSS, that is physiological salt solution, as a frog ringer solution, as a PSS. Then it requires drug, that is acetylcholine, the stock solution of acetylcholine which is prepared, that is 1 mg per ml, and a drug physostigmine, and the stock solution of physostigmine is 10 microgram per ml. So this is the drug requirement. Next is the instrument and equipments. Instruments or equipments for performing today's practical. So student organ bath, then Sherrington rotating drum, kymograph paper, scissor, frontal lighting lever, 1 ml syringe, forceps, and napkin. So these are the various requirements of performing today's practical. Okay. So next we will discuss the theory behind today's practical. So what is the theory of today's practical? So physostigmine is a reversible inhibitor of acetylcholine esterase. So the enzyme that degraded acetylcholine. Means what? That acetylcholine esterase is the enzyme which is responsible for degradation of ACH, and physostigmine which block that enzyme. By blocking that enzyme, physostigmine potentiate the action of acetylcholine, means it potentiate the contraction of rectus abdominis muscle. Okay, so that is the theory. So it increases the concentration of acetylcholine, which cause stimulation of both muscarinic and nicotinic receptor. Means that available acetylcholine which binds with muscarinic and nicotinic receptor, which shows increase in their action due to physostigmine. So thus the presence of physostigmine increases acetylcholine induced contraction of rectus abdominis muscle of frog, and that effect of physostigmine is known as potentiation of acetylcholine action due to increasing the action of physostigmine, that we call potentiation action of acetylcholine. So this is the theory behind today's practical. Okay, so next we will discuss the procedure. Okay, we will discuss procedure. So before starting the procedure, we will discuss the assembly setup for performing today's practical. So what is the assembly required for performing today's practical? So the assembly is same that of the experiment number 4. Let me see some videos of assembly setup.
Assembly setup. The assembly setup for experimentation of frog's rectus abdominis muscle preparation consists of organ bath.
Action.
The organ bath consists of an outer jacket, which is also known as water bath, made up of steel or glass. Organ bath also consists of thermostatically controlled heating rod, which maintains uniform temperature of water in outer jacket. It also consists of tissue bath made up of glass with a capacity from 10 to 50 ml with both sides open. Isolated muscle preparation is mounted in upright position in this tissue bath. Aeration tube made up of glass has dual functions. One, it will aerate mounted muscle preparation, and second, it serves as the tissue holder. The other end of tube is connected to aerator. The bottom end of tissue bath is connected to rubber tubing, which serves as outlet. The bottom side of organ bath consists of an outlet for removing water from outer jacket.
So this is the organ bath assembly. So look this here. Next, recording lever, that is frontal writing lever setup.
Recording lever. To record the responses of drugs on muscle preparation, one can use either simple lever or frontal writing lever. Frontal writing lever is made of light aluminium and is designed in such a way that the writing tape rotates freely on its axis. For proper recording of responses, adjustment of magnification of lever is necessary. Magnification value is calculated by using the following formula. Magnification value is equal to distance between fulcrum and writing point upon distance between fulcrum and the point of attachment to the tissue. For recording the effect on frog's rectus abdominis muscle, 5 to 10 full magnification is required. For proper recording of responses and for proper relaxation of muscle preparation after drug effect, application of proper tension or load is required. For example, for frog's rectus abdominis muscle preparation, the tension prescribed is 1 to 5 gram. This tension is applied on longer arm of the lever.
So this is frontal writing lever setup. Then you will see the video of Sherrington rotating drum.
Sherrington's rotating drum. It is also known as chronograph. It consists of circular drum, speed regulating gear, shaft to which drum is connected, and main on or off switch. It has clutch lever, screw lift to alter the position of drum, and electrical striker. Thymograph paper is wrapped on circular drum and is smoked with black smoke of kerosene or benzene.
So this is the assembly setup which is required for performing our today's practical. So next, that is isolation technique. So how to isolate rectus abdominis muscle of frog. So we will see this video of isolation of rectus abdominis muscle of frog.
To study the effect of acetylcholine on frog's rectus abdominis muscle, select healthy frog. Pick the frog with the help of picking needle. Now, pin the limbs of the frog to dissecting tray. Remove the abdominal skin to expose rectus abdominis muscle. To isolate rectus abdominis muscle preparation, take side cut on rectus muscle. One can prepare two muscle preparation from a single frog. Now, tie a thread to the bottom and top of rectus muscle before removing muscle from the body of the frog. Mount this rectus muscle preparation in upright position in the organ path containing frog ringer solution under a tension of 1 to 5 grams. Now relax the tissue or muscle for about 45 minutes, during which wash this preparation with fresh quantity of ringer for at least 3 times. Now this preparation is ready for experimentation.
This is the isolation technique of rectus abdominis muscle isolation. So next we will discuss the procedure. This is the procedure. We will see the video of procedure.
We have already learned the isolation technique of frog's rectus abdominis muscle and the setup of assembly. Now stabilize the mounted muscle preparation for 45 minutes in frog ringer solution. During this period, wash the muscle preparation with fresh quantity of frog ringer for at least 4 times. Start the trial after stabilization. Take baseline for about 30 seconds on smoked paper. Now stop the trial and inject 0.1 ml of acetylcholine solution in the reservoir containing mounted muscle preparation. Start the trial immediately. Record the contractions for 90 seconds. You can see upward movement of writing tip of frontal writing lever on smoked paper. Stop the trial. Now relax the contracted muscle by rapidly washing with fresh quantity of frog ringer. Because of this, writing tip of lever slowly reaches towards baseline. Repeat the procedure by using 0.2, 0.3 and 0.4 ml of acetylcholine solution. For recording of each response to increasing doses of acetylcholine, 30-second baseline, 90-second response time and total 5 minutes time cycle is to be followed. Now measure the height of each response in millimeter. Height of response is indicative of muscle contraction. You can see that with the increasing doses of acetylcholine, muscle contraction increases. Hence, we can say that cholinergics increase spasmodic action.
Now we will discuss stepwise procedure as we have seen the videos of starting procedure. So detailed procedure, now we will discuss the detailed procedure of performing today's experiment, that is the effect of physostigmine on DRC of ACH. So first, frog rectus abdominis muscle preparation was mounted under 1 gram tension in organ bath containing frog ringer as a physiological salt solution and kept it for 40 to 45 minutes for stabilization. Okay, and that procedure of isolation we have seen in last video. So first of all, mount that rectus abdominis muscle preparation for 40 to 45 minutes for stabilization. So next, the response of acetylcholine solution were recorded in increasing order, that is 0.1 ml, 0.2 ml, then 0.4 ml, then 0.8 ml. So that increasing dose of acetylcholine solution becomes recorded until the selling effect was observed. Selling effect nothing but at the dose the maximum response, which is maximum response. After the maximum response, after that dose, it shows a same response or less than that of the response, that we call selling effect. After recording the effect of acetylcholine on various doses, then next step is that add a physostigmine, that is 2 microgram per ml concentration, which is added in physiological salt solution reservoir. Means we have to add physostigmine in our PSS solution. After addition of that physostigmine, that PSS is called as E-serinized PSS. E-serinized PSS means which consists of physostigmine. Physostigmine also known as E-serin. Okay, so after that we added physostigmine in PSS reservoir and irrigate the tissue with E-serinized PSS for 30 minutes. After addition of physostigmine, we have to irrigate that isolated tissue preparation with E-serinized physiological salt solution for 30 minutes. Okay. So next, that in presence of physostigmine, again acetylcholine responses were recorded in the same pattern as above, like 0.1 ml, 0.2 ml, 0.4, 0.8, 0.16, 32, 64. Okay, up to selling effect we have seen previously. Okay, so this is next record effect of physostigmine with acetylcholine on with same dose like 0.1, 0.2, 0.4, 0.8, 0.16, 0.32, 64. Then the height of responses in presence and absence of physostigmine were measured and calculated the percent response obtained at each dose by considering the maximum response of acetylcholine without physostigmine as 100%. Means consider a maximum response of acetylcholine without physostigmine as 100%. Means first step we have performed with only acetylcholine. So for that, the maximum response consider as 100%, and after considering that 100%, that remaining doses will be compared with that 100% response. Next, that is percent response versus log dose of acetylcholine graph was plotted using the data obtained with or without physostigmine. After that, we have to plot a graph of percent response versus log dose. So here is observation table, observations of today's practical, recording of effect of physostigmine on acetylcholine dose response. So at the start we have recorded only acetylcholine effect. At the start we have recorded acetylcholine effect for 0.1 ml, then 0.2 ml, 0.4, 0.8, 1.6 ml, 3.2 and 6.4. So what is the observation? That is for 0.1 it consists of 12 mm height. Then after increasing the dose, that is 0.2, it consists of 14 mm height. Then 0.4, it consists of 20 mm height. Then next 38 mm height. Then next dose, that is for 1.6 mm, it consists of 56 mm height. And look at the dose 3.2 ml. So 3.2 ml, which shows a maximum response, that is 70 mm height. So it is maximum response, means consider that response as 100% response. Consider that dose, that is 3.2 ml, as a 100% effect. After that, next, that is 6.4, it produces height is 67, means it decreased after that dose, means that dose is called as scaling effect. Sometimes the next dose will be same as previous one, means it may be 70 ml. Okay, so that consider that dose as a ceiling effect. Okay, so this is first step, that is effect of acetylcholine without physostigmine. After performing this, we added physostigmine in our PSS solution, that is we called E-serinized PSS, E-serinized physiological salt solution, and irrigate the tissue for 30 minutes. After 30 minutes, we have to perform the same procedure. Again, we have recorded the effect of acetylcholine with physostigmine at same doses like 0.1 ml, 0.2 ml, 0.4, 0.8, 0.8, 1.6, 3.2 and 6.4. So after recording these responses, we have to calculate the graph, that is percent response versus log dose. So by comparing with that 3.2 ml as a 100% response, measure the percent responses of that acetylcholine with physostigmine produced the effect. So this is the effect of physostigmine on DRC of acetylcholine using frog rectus abdominis muscle preparation. So these are the graphical representation. So next, look the observation table. So concentration of acetylcholine solution we have used, that is 4 microgram per ml. So these are the responses for first step, acetylcholine only, that is without physostigmine. And here the observations of physostigmine with acetylcholine, means after E-serinization. Okay, so for 0.1 ml we have injected the volume of acetylcholine 0.1, 0.2, 0.4, 0.8, 1.6, 3.2 and 6.4. So this column which indicates a response, that is for 0.1 12 mm, for 0.2 14 mm, 0.4 21 mm, then 0.8 38 mm, 1.6 56 mm, and 3.2 70 mm. It shows a maximum response at 3.2 mm. 3.2 ml means that dose is considered as 100% response. Look this. And after comparing as 100% response, calculate the percentage of remaining. Okay, means consider 3.2 as 100%. Then what about 0.1? So by considering that 3.2 ml dose as a 100%, calculate the remaining percentage of responses. As like again see the effect, the responses of physostigmine with acetylcholine. So see for 0.1 ml compare. Look this, for without physostigmine it shows 12 mm height, and with physostigmine it shows 15 mm height. Means with physostigmine the acetylcholine shows potentiation in action. So look the percent response. So for 0.1 ml it shows 70% response, while with physostigmine acetylcholine shows 21 or 22% response. Means acetylcholine with physostigmine which potentiate the effect. Okay, so look at another effect, that percent responses with physostigmine and acetylcholine becomes potentiation action. So this is observation table. So next is the graph. By plotting graph, we have to plot a graph of percent response versus log dose. So percent response, log dose. So values of that percent response. So this is percent response for acetylcholine without physostigmine, and this is for percent response with physostigmine. So we have to plot both graphs with log dose, percent response versus log dose. So here we have plotted the graph percent response versus log dose. So this shows acetylcholine S-shaped graph, sigmoid shaped graph, that below line is showing the response of without physostigmine, that is only for acetylcholine, and left side graph, left side line which indicates physostigmine with acetylcholine. So from the graph it is concluded that physostigmine which shifted the graph towards left side, means after addition of physostigmine with acetylcholine it shows a potentiation effect, means that graph becomes shifted towards left side. So by shifting that towards left side means it potentiates the actions. If graph shifted towards right side, then it decreases the action. But here the graph which is shifted toward left side means physostigmine shows potentiation effect with acetylcholine by blocking enzyme choline esterase. So this is the graph of percent response versus log dose. So last report. So physostigmine shifted the dose response curve of acetylcholine towards left side, indicates the potentiation action of physostigmine on acetylcholine induced contraction of rectus abdominus muscle. So this is the report, means after addition of physostigmine the response of acetylcholine becomes increased due to physostigmine. So thank you. Here is the end of today's practical. Thank you.